recording here. I may just post the first section or the second section. Or actually, since I have both recordings, I'll post both. The Yeah. So to answer your question, the question being, how do you compare Dash to Flask? Dash, like a Dash app, is um, it is a Flask app. I'm trying to find the word where a class inherits other classes. I forget the word. But essentially, a Dash app is inheriting. It inherits everything that a Flask app has. So if you look at and I don't know if anyone here tried to deploy Dash apps yet. Yeah, it's not required for the. I'm sorry.
Yeah, I mean, I do have a shared server
Hmm.
through GoDaddy actually, and I was looking at how it's done, and apparently you have to use CGI rather than WSGI for that particular shared server, and it can be a bit complicated, but no, it's something that I'm very look. I guess Heroku, and Docker seem to be the main ways to do that.
Yeah, Heroku. I actually haven't. Yeah, I have no familiarity with. I didn't even realize they were getting into the sort of cloud space in that way. But so I don't have experience there. And usually, um, like in my experience, like Dash apps work best in sort of these more Heroku-like environments. Like IBM has, like Bluemix, I think it is that it's similar. And I'm forgetting the other cloud providers' versions of it, but there's basically anywhere you see the ability to host a Flask app, you would um, with some work be able to host a Dash app because it is just a Flask app at the end of the day. And yeah, and the gateway I haven't really dug into that much, but email me if you are running into issues there, and I could see what I could find out there. And also, just to reiterate for you and anyone else that it's not required to host the Dash app because even on a service like Heroku, the it's it's more intense than hosting a Shiny app, and I would rather everyone focus on just getting their Dash app to work locally rather than try to get bogged down with trying to get it hosted.
Okay.
Cool.
Yeah.
So, any other questions about Module 4 and also about anyone's experience so far with the final project proposals, which are going to be due along with Module 4? Cool. So actually, just to start with the final project proposals, those will be due along with Module 4. So they'll be that the place to host that is the place to post that is in Blackboard along with Module 4. If anyone's not seeing the final project proposal um, place to submit it, let me know and I'll make sure that everything is there. But it should just be along with Module 4. And for the final project or for the proposal, really, I just want everyone to begin thinking about what sort of data they're going to be using, what topic they're looking at, and what kind of and really what are they looking to display to an end user? What are they looking to communicate to an end user? And the sorts of things I focus on in terms of the final project proposal is trying to focus on open data sources. So the there are a lot of open data sources out there coming from governments, cities, we're actually using for module 4. I'll get into using the Socrata API, which is a good source of data. And and basically you're going to be creating a data product out of these sources. So, the sorts of things you'll need to be thinking of is, try to put yourself in the mind of a user and think, I have this data set. What would, what would someone be trying to find out from this data? So, one of the common themes I reply back to with the proposals, with feedback, is I sort of think of things along a spectrum of either being an exploratory app or something that's more narrative. So on the exploratory side, really thinking of it in terms of you have your data set and you want users to be able to really explore it on their own and come up with their own conclusions, whereas narrative is kind of more guided, with, you sort of have your own thesis that you're trying to communicate, and you're using a more narrative structure to present that to an end user. And, so in terms of tools, I'd like you guys to use some of the, one of the tools the frameworks that we're sort of working with, especially towards the latter half of the class. So, really Shiny, Dash, or D3 or other JavaScript libraries if you choose to go down that route. We're going to be getting into that with modules 5 and 6. And then in terms of other tooling, the things like a notebook or R Markdown. If basically, I want to encourage students to sort of add interactivity to their project. If you do feel that, so using the spectrum I mentioned before, if you are looking at more of a narrative structure and you find that something like R Markdown or a Jupyter Notebook would serve you well in that way, and you're able to sort of, you feel it's really serving your thesis, sort of your main point, then I would, I don't want to just totally forbid using those tools, but I would like to kind of encourage the more interactive frameworks that we're working with. And with that, it looks like we have a few more people here, so we could move into a bit more of what I wanted to go to. But since it is only 5 of us, feel free to ask any questions you may have, and we could sort of go wherever we need to. So first, what I want to go through is just to quickly go over the first, to go over assignment 3. So let's get to that. And I'm sorry, I'm not sharing my screen yet, am I? Is everyone seeing my screen now? So luckily we didn't miss much. I was just going through the final project proposal in GitHub. But now that we're looking at an app, it would be helpful to see my screen. So let me reload this. And actually, I'm sorry, let me get back to where I wanted to go.
Professor, just looking ahead to module 5, is that more Flask or is that the D3JS?
So module 5 is actually and I'll put out an announcement for this because I actually had meant to include another more introductory JavaScript assignment here. I thought that's what I had in module 5. So yeah, I'll sort of keep this here just for reference because it may be useful if people want to delve into it, but I'd rather focus more on JavaScript than focus on Flask since we are already using Dash. So, so yeah, I hope not. I don't think anyone got a head start on this one, but I'll put out announcements there. So thanks for bringing that to my attention. But Module 5 will be focused on kind of introductory JavaScript, and I'll go through some of the fundamentals of D3. But really, it's like I treat this course as a survey, and it's difficult to get into. It's obviously difficult um, to teach JavaScript in less than half a course. So it's really trying to touch on just giving everyone enough knowledge to get yourselves in trouble with JavaScript rather than to be able to, you know, um, this isn't meant to be sort of a full web development course. But thanks for bringing that to my attention. I'll make the change there. Anything else about the later modules? Cool. Cool. So I'll make sure to change that as soon as possible, and we'll get back to assignment 3. So for assignment 3, we're looking at data from the CDC. And this is similar to what we were looking at with assignment 1, where it's kind of a pretty traditional multidimensional tabular data set. We have different disease types, different states and years. So we have our time dimension. We have and then we have various filtering dimensions of states and disease types. And then we have some measures for all of these. So looking at deaths, populations, or the crude rate. And we had 2 questions to answer for this assignment. So the first one, we wanted to just look at a point in time and be able to compare death rates across different states. And then for the second question, we wanted to sort of add that time dimension back and be able to pick particular states and see whether they're improving their mortality rates faster or slower than the national average. So with that, let's just delve into what I came up with for the app, and then I'll quickly go through how I made it happen in the code. And then in terms of everyone else's experience with Shiny, were you able to, was this your first time using it? And if it was, like, how did you find sort of the ability to, begin to get up to speed and build an app similar to this using this data?
Yeah, it was my first time to actually doing a Shiny app, and I was amazed at how easy it was, really, and how quickly you could get things going.
I'm sorry. Can you repeat that? I missed the first half of that.
It was my first time creating a Shiny app, and I was really amazed at how easy it was to do. I mean, I wasn't expecting to be able to get things going, within a few hours.
Yeah, no, it's definitely and hopefully you'll find that Dash is similarly built in that way, where like if you are used to using the environment, if you're used to using Python, then Dash is definitely a smaller learning curve than trying to build raw Flask apps or other sorts of web development.
Yeah, and I went along with the data camp video. I think there's a guy, Dean something, Eltrati, or someone who has a site, and he walked through it on data camp. So I was able to just take the code from that and apply it to this project.
Mm-hmm. The code from data, and that was for Shiny or for Dash?
Yeah, for Shiny, there's a data camp video for Shiny, and basically pasting some of the code from that and making adjustments tended to work pretty quickly.
Mm-hmm, mm-hmm. Cool. I'm glad to hear that, and I'll actually I'll try to find try to find that, see if that's useful for providing as a resource in the future. But yeah, so I'm glad there was good experience in terms of using Shiny. And so yeah, I'll just quickly go through what I had here for my questions. So I chose a pretty simple layout. We were just looking at, for both questions, we're going to be picking by disease type. For question 2, we're picking by state. So I just kept both of those visible. And for the first question, we're just really comparing by state. So I decided, in this case, to really take the maximizing data to ink ratio to its extreme. And in this case, we're kind of utilizing Plotly's interactivity to in service of this. So with in the first question, in the first assignment, we were also looking at state-wise data, and it kind of gets it could get difficult to try to include all of the state labels. For question 1, for the first question in that first assignment, I sort of had students rely on a vertical layout to allow there to be room there. But in this case, I'm sort of allowing there to be more flexibility and just utilizing the functionality of Plotly. So being able to, through tooltips, get the state that each of the points are referring to and have the user be able to explore them. And then, in this case, we're just simply doing different disease types. So once we do that, we're able to, get an idea of what the crude death rates are in each case. And then I'll go through just both the questions here, and then really awesome. I just saw Zach posted some of the resources he was looking at. So for anyone watching the recording, we could look at that, but I'll just go back here. And then, so for question 1, you're just highlighting over to get the states. And then for question 2, there was a bit more calculation that needed to be done. We needed to be sure that we had the correct that we had the correct national average weighted by population, and get an idea of how things are improving over time. So in this case, we now are able to utilize the state selector, and we could get an idea of how things are, comparing across states, and in particular, how is that, sort of comparing to the national average. And for time series graphs, usually lines are a pretty good way of showing that. And then just to quickly get into the code behind all of this, with Shiny, the UI elements are really, really slick. You just have your kind of built-in panels, so things like side panels, main panels, and for your what I chose to use were tabs. So it has a built-in tab panel that lets you just easily tab back and forth between your between the different questions in this point. And we'll notice a similar pattern with when we get to Dash, but we'll be keeping track of what our IDs are here because we'll be referencing them in the server object. And then because we are using this disease filter in both questions, I decided to separate that out into a reactive block. Although, as I mentioned when I was introducing Shiny, the reactive blocks aren't really necessary for speed enhancements. We're dealing with a small enough data set where that doesn't matter. And then really the only things that else that we have are these plot one and plot two. So, for plot one, we're just adding the filter of the year. But otherwise, we're using the same measure, sort of just the provided measure, the crude rate, and then plotting that out using, in my case, Plotly. And then for the second plot, we have, and the way I decided to do this was just to create um, a separate data frame where we're looking at the national average. So in this case, I'm, using some dplyr functions to summarize my data and create my weighted mean. So, really all we're doing is throwing in crude rate along with the population as our weights, and that gives us the weighted mean that we need. And then you could see a few other functions that I'm getting here, but basically I'm calculating my national average here. I'm calculating my states or getting my state level data here, and then um, just kind of R binding the two of them. So, and I don't want to waste too much time just getting into this data, but just to sort of give an idea of what this looks like. Essentially, I have a separate, what this ends up with is, I'm able to, for each state, get, the national average, and then, sort of have that be what I'm coloring by. Um, so when I do that, I'm able to, sort of filter by state and get those two as something I'm separating the traces by. So with that, any other questions on Shiny before we move on to Dash and using and then sort of some special content on using the Socrata API?
Professor, I'd kind of like to share what I did for this homework. I don't know if it'd be possible to show it.
Yeah, definitely. Let me make you presenter.
Okay.
And you should be able to just hit play to show your screen.
Okay. Is it showing up?
Yeah, nice. I like this. That's it's similar to what I was doing. It's a Cleveland dot plot. Yeah.
Yeah, I saw it as a lollipop plot, and so basically I set it up here, and what I did is I loaded a built-in data set in R, which showed the states according to region. So I set up this button here, so you could sort it. It's sorted from highest to lowest, and then you can sort by region here, and it breaks it up into the four: Northeast, South, Midwest, and West, according to that. And then also this drop-down menu with the years. I wish I had done the tab sets that you just showed, or is that what they're called, the tab set?
Yeah.
I actually did it two separately. So in the other one I did here, I used an area plot with different shading here. So let's see. To show the blue is the state trend, and the gray is the national trend. So you can kind of see how they track against each other.
Awesome. This is great stuff.
Yeah, so I just wanted to share that. Pretty proud of that. Thanks.
Yeah. Awesome.
Go back to you.
Cool. Let me make myself presenter again. Cool. And is everyone seeing my screen again? Cool. Looks like I am. Awesome. And any other questions on this assignment? Then where do I want to? I want to move here. Cool. So with that, we'll move on to module 4, and I want to sort of just start going over this notebook, looking at the Socrata data, and really give an idea of what I was aiming to do by having students use the Socrata API. In previous assignments, it's really been we'll just download the data, and you're pretty much dealing with it in memory. So even with the larger data set that we were looking at with the Pluto data set, you still have you're ultimately reading in all of these rows, and you're sort of manipulating everything using pandas. But as you're building more complex web apps, the you begin to run into the limits of how you're able to work with the data. So the data set that we're using is this is actually a really cool one. This is the 2015 tree census coming from New York City. So this was an attempt over a few years to pretty much catalog every single tree in New York, and give a clearer idea of different types of really what sorts of trees are living in New York. And the so you could kind of get an idea of what kinds of what the size of the data set is. Even at 600, around 600,000, that's something that you would still be able to bring in memory ultimately. But the but the API itself, as you'll see in the notebook, um, gives some limits in terms of how you're able to use it. So the first thing that I sort of walk through is, we have our API endpoint, and if we just tried naively to just grab all of our data, we see the trees endpoint. I want to grab all the trees and just get a full data frame. So if you try that, looks like you kind of have what you want. You have all of your columns. The head of the data frame is showing up okay. But if you look at the shape, you kind of get an idea of that something is amiss. Like we know that this by checking that site that it has 600,000 rows, and even if you didn't know, check that out first. 1,000 is a suspiciously small number for number of trees in the entire city. And what's actually happening here is Socrata places 1,000 row limit on their API. So and the example I sort of walk through here is you know imagine if imagine we're not sort of creating any sort of visualization. We just want the ability to just show these records. And let's say we're making like a mobile app where there's not that much screen real estate, and we only want to show five records at a time. The the way that that would sort of work with this API is you would call you would call the API for those first 5 results, get them, and then as a user is clicking next, getting more data, you're actually going back to the API with each of those interactions and returning the new data set. So,
Hey,
yeah. Hello? Okay. So yeah, you're actually just paging through these results, and each time you're paging through, you're getting you're getting new results. In this case, it's using this offset argument here. And as so here you could see like this is the first 5. If I set my offset to 5, that would be the next 5 uh, rows here. And so this is really how you would do it if you wanted to view just all of these results one by one. But more importantly, there are other what are called Socrata query language functions. So if you go to the page here, you have information about paging, and then you also have on the left-hand side here information about various SOQL clauses. So and a lot of these I mentioned in the notebook should be reminding you of SQL. So you have your kind of select different columns, using where to filter, ordering, and then grouping. So similar to group by in SQL. And the example that I give here is, you begin to think like, we're not paging, for this app, we're not going to be paging through results, but, let's say we wanted to view a count of each species of tree in the Bronx. So we're looking at a single borough where, and we want to get count. So you could see we're building our query in a similar way that we would be, building it in something like SQL. So we're starting out by just selecting which columns we're looking at. We have our where clause. So in this case, we're filtering by the Bronx. And then we're grouping. So in this case, we're grouping by species. We want to get a sort of count for each species. And from the point of view of an API, the way to think of what we're doing here, and this maps back to in our last lecture when we were talking about client side versus server side, really what we're doing is we're relegating our data processing to the server side. We're kind of making a conscious decision to do that. And on the client side, like from the client side's perspective, it's receiving a data frame with 2 columns and 133 rows. So, essentially, we're kind of offloading that more expensive calculation. In this case, it's not too bad, but for with a lot of modern web apps, you're doing a lot more expensive calculations, and you're offloading that to a server where you have the bandwidth to do something like that, and then returning only the results that are needed to the app itself. And the reason why I wanted to really integrate this with the Dash module is to, really kind of give everyone an idea of what you should be thinking of as you're building these web apps. When you are using RStudio or Jupyter, there's a tendency to, really think you could just strong arm the data. And, you're prepared as a data science professional working in Jupyter to sort of have an expensive operation run and go get a cup of coffee. That that's going to happen, and Jupyter itself is able to sort of run a longer operation like that. With When you're building a web app, you need to think more, in terms of is a user going to be sitting there forever to wait for these calculations to be done, and B, with a web app, you then also need to think about, what happens if something times out? What happens, if there's sort of something too complex happening and the whole thing fails? Is it just going to start again? Does that mean the whole app just errors out? And I kind of wanted people to begin thinking of building their apps with this, with these sorts of things in mind. So here, in Dash, it abstracts away a lot of client versus server side. You're not thinking too deeply about each side there, but using an API like this, it's kind of forcing you to think more about what are you offloading to that server side. So that's what and then just kind of a last note on dealing with, some some wonky figures with spaces. But aside from that, really that's what I'm aiming for with Module 4. And then to bring it back to the questions, we are in particular looking at the health of trees and then looking at the stewards variable. So trying to see if tree stewards are what sort of effect they are having on the health of trees. And I'll leave it up to everyone to sort of part of the assignment is then to try to find out how best to show that. So any questions on Socrata before I move on to Dash itself? Cool. So moving on to Dash, and this is going to be a quick intro. I posted a video that kind of walks through Dash that would be very useful, and also the just looking, just kind of going through the tutorial step by step here is also a very useful way to look at all of these concepts. This is written more in a um, not sort of a full reference, but more a kind of episodic going through all of the major concepts that you'll run into in programming Dash apps. And so I'll sort of leave everyone to kind of start out with the installation and layout. And actually, one thing before I delve into a few key points here is to talk about running Dash apps. So a few students have been asking me about running Dash apps in Jupyter Notebook. It is possible. There is this library here called Jupyter Lab Dash, and this would let people there we are, Jupyter Lab Dash. So this lets you run a Dash app in your notebook. So you kind of have an idea of what that ends up looking like in a Jupyter Lab environment. But and if you're comfortable if you're more comfortable in a Jupyter environment like this, definitely feel free to work with it in this way. But one thing I like to encourage with Dash is to really go more minimalist with it and sort of try to run Dash apps directly from the terminal. So just terminal in your Mac, or if you're using Windows, just CMD to get into the command prompt. And the like honestly, the way I work with Dash apps is I usually just go directly from the terminal, and I just use a text editor to create my apps. So definitely, I don't want to enforce using a text editor, but if you are more comfortable in Spider or in Jupyter Notebook, feel free to use those options. But I just wanted to kind of bring to light some gotchas if you want to try using the terminal, and this may be one of your first times sort of using Python from the terminal. And the main thing I would watch out for is to make sure that you're using the correct environment. And so if you're using, and I imagine most of you are using Conda. With Conda, it should just by default activate your base environment. So normally, if you start your terminal, you'll probably see this parentheses base. That means that your Conda environment is activated. If you need to activate it, you just Conda activate base, and that will activate the correct or whatever you named your environment, and that will activate the correct environment. And then once you've done that, you could just sort of navigate around to the correct path. And then when you use Python like this, you're referring to your environment of Python. All of the libraries that you have installed are going to be accessible. And when you start from the terminal here, you'll see it kind of hangs. This is the server itself, sort of running. And you'll be given a URL. You can go to 127.0.0.1. That's the same as what's called localhost. So if I go to localhost colon 8050, which by default it's deploying to that port, but you do have the option of choosing which port you want to deploy to. And once you get there, you'll be able to see your Dash app. And the Dash app, so that's just a bit about sort of running Dash apps from the terminal. And then this app here is kind of what I wanted to start off with. So I definitely recommend going through the full tutorial to get a handle on everything. But the app I wanted to start with that kind of includes all of the major elements, but in a very simple way, is this app here. And so just in terms of what the app is doing, it's pretty simple. All it's doing is parroting back what I'm writing into an input box. So very simple interactivity that we could then see, sort of get a clear idea of how Dash is working. So there are two main components to a Dash app. The layout maps pretty directly onto Shiny, like when you have your UI object. So here it's a very simple layout. We just have our input and our target where we're putting our output. You'll notice it's a bit more base than what you're seeing in Shiny. So with Shiny, you have kind of more pre-canned concepts like sidebars, main panels, etc. And with Dash, you're kind of working with more raw elements. So really divs, like these are all HTML tags. So the HTML library is bringing in anything from there, and then there's DCC Dash core components, and these are the interactive components. So there's a reference for all of the components that are available, but really these are kind of tailor-made for Dash interactivity. I'll get into how that's happening. So this block here is the Dash analog to what we do with Shiny in the Shiny server object. So in the Shiny server object, you're sort of dealing in one object with kind of all of your outputs and inputs at once. With Dash, things are separated into what are called callbacks. So you have your output. In this case, output is meant to be a single output, although recently the ability to add multiple outputs was added. And your input, even though we only have one input, is in a list. So if we had multiple inputs affecting the output, we would just be appending them into this section here. And before I get more in depth in terms of explaining outputs and inputs, I want to go back to another section here where really what we're doing is we're focusing on our outputs. So using this architecture we went through last lecture, we would be focusing on our info box and our graph. And we have, lists of the input. So for this info box, we would have a list of 3 inputs. For this graph, we would have a list of the 2 inputs here. And um, and so, really the way to deal with the classic way of dealing with multiple inputs is to have multiple callbacks. But recently, support has been added for multiple outputs. So you could actually approach something that's more similar to what you would be running in Shiny. But for now, I'll just focus on singular outputs. And similar to Shiny, we're accessing each of these outputs and inputs by their tags. So my div is referring to my div there, and then my ID is referring to my ID here. And what Dash adds to this concept is looking at component properties. So, and I guess this is similar to in Shiny where you are accessing the input object and the output object, but with Dash, you're defining it within the callback. So what we're saying is the children of this div, which in sort of HTML, children means something like this. So if you're writing raw HTML, these 2 elements are the children of this div. So whenever you see these sorts of nested elements, that's what's happening. And then lastly, we're just returning a formatted string. So all we're doing is taking in, and I'm sorry, by the way, we have a number of inputs, in this case 1, and that number needs to match the number of arguments that are going into the function. So if we had 2 inputs affecting this output, I would have 2 arguments here, and we just simply take that and then return the formatted string. And then to delve a bit like this into what's happening with the callback definition, this is what's called a decorator in Python. And the way to think of it is just it's just above a function. What it actually is doing on the back end is it's using this function as an input to sort of this app.callback function, but it's more elegant to show it as a decorator in this way. And really you have your function that's going to be called each time the output is triggered, each time the input is triggered rather, and you have your decorator here, which is tying that function to your input and output. And then lastly, you just have this block here, which is actually running your app. And we don't have much time left, so like basically, this is covering all of the major elements of a Dash app, and then as you sort of go further into the tutorial, you'll see different iterations of this. So, for example, when you do begin adding actual visualizations to your app, you'll see that we're changing what we're accessing in the component property. So here we're creating we're returning a figure rather than just the children of the previous div. So because we're returning a figure, you could see that we're kind of matching the form that it's expecting. And definitely recommend kind of going through these, and this should give you kind of a nice overview of the concepts that will help you with Dash. So any other, oh, and I see Zach, you asked a question with so Zach was asking about file structure of separate apps, so things like um, uh, main templates, config, uh, the and the, so this isn't common for Dash apps because the layout is fully so basically with Flask, um, rather than really thinking of like Flask is more a back end service. So going back to our our kind of breakdown here, the a lot of times you could, and actually for the assignment I accidentally posted, a Flask app could pretty much just be returning data. So Socrata API is returning a JSON blob of data, and that's sort of something a Flask app could do. And what Zach is referring to with these, templates use.py is essentially, how to render the front end. With So you don't really deal with that with 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 Dash. The exception being config, and config comes into play when you're thinking of deploying your app. So again, deployment isn't necessary for assignment 4, but if but for if you do want to play around with deploying an app, you'll see things like adding your config, adding a requirements.txt file to make sure that your Python environment is set up, and that's also something that's included in the tutorial here. And then in terms of Bootstrap, the so Dash accepts external CSS, and this and actually sort of this is our default Plotly's default CSS, and it has some pretty good go-to styles. The so and this includes sort of a grid style layout. In some of these examples, you'll see. I believe there's an example here. Otherwise, you'll have to dig into the um, oh, I'm not finding it here. So I'll so basically in some of the gallery examples, you'll see a you'll begin, and this is kind of getting a bit more in depth. So the short answer is don't worry too much about formatting. I'd rather everyone focus on the sort of getting the logic of their app working first, and focus on the visualizations rather than focus on the layout of the app. But the it's not what I wanted again. There we are. Oh, and this is using a different one. So so basically to just quickly live code something here. If I wanted a so what Zach mentioned about Bootstrap, Bootstrap is a CSS library, and and actually I think this is technically grid CSS. Um, I'm pretty sure this one includes Bootstrap, so it is, responsive. So something like this is responsive if you're resizing your app. But this is the way that you could think of this is, I have this master div here where it's being defined as a row, and I have, and each row has 12 columns. So here I have 6 columns and 6 columns. So this is essentially giving me a, sort of 2 equally sized sides. And if I wanted to sort of resize those cells, I could make this 3 and 9, as long as it's adding up to 12. And then you pretty much nest these rows or columns to really create any sort of tile layout you wish. And so again, I don't want people to focus too much on CSS styling. I would rather you focus on sort of the logic of the Dash app and on the visualizations that you're producing. But this is a useful tool to, at least get some, some advanced layouting available. So any other questions here? Cool. Cool. So, so with that, especially for just a few logistics to mention. I know I'm behind a bit on grading, so but after module 4, I will be sort of focusing on. I'll be prioritizing the final project proposals. So expect those back early next week, and I'll be including guidance on, in particular, module 6, which is, meant to be really in service of your final project. It's, more a static visualization or kind of a rough draft, if you will, of what you're producing for your final project. And usually what I do with the proposals is I'll, provide in my feedback specific things to focus on for module 6. So for example, um, if your proposal has a really great sort of thesis, a good formulation, but maybe one of your data sets is slightly problematic and it may take some manipulation to really get it to the point that you need to, I would probably direct you to sort of focus on that to make sure that this is a data set that you're able to use, and try to get it in, you want to sort of create X visualization with it, try to get it to a point where the data to a point where you would be able to use it in that way. Um, and yeah, so I'll be prioritizing that. I'm also hoping later this week to get some more of those homeworks graded for you. And that's pretty much it. So anything else? Any other questions? All right. Cool. So good luck, everyone, on Module 4, and I'm looking forward to seeing everyone's final project proposals.
Thank you.
Thanks a lot. Have a nice night, everyone.
You too.